maximum compressive force 100 kilonewton and the working stress for steel is 10 kilonewton per meter square. The figure is shown below. So here the given diagram, these are the bolts of diameter D and they are indicated by N. Here we will have to we have two questions. This is a common data question. It consists two questions. The first question is determine the diameter of the steel bolts. Steel bolts N of press. Here the options are 1.41 meter, 2.52 meter, 3.63 meter and 4.74 meter. And here the second question is determine the total elongation of the bolts at the maximum load if the length between their heads is 50 meter and take E is equal to 200 gigapascal. And here are the options. So here first we'll have to find out the diameter of the bolts. So here the first write down the given data, that is the allowable stress is given by that is the working stress is given by 10 kilonewton per meter square and the maximum compressive force is equal to 100 kilonewton. So this 100 kilonewton is resisted by two bolts, so that the stress induced in the members is equal to P by 2 times the area of those two bolts, because the bolts are having equal diameters, so that the area resisted by the bolts is equal to 2 times the area of one of these two bolts, and which is equal to, which implies A is equal to P by 2 times sigma, which is equal to again 100 kilonewton, that is 100 into 10 cube by 2 into 10 into 10 cube, which is equal to 5 meter square, and it is equal to pi by 4 d square, where d is the 2.52 meters. So here the diameter of the bolt is equal to 2.52 meters, and in the option the right answer is B. B is the correct option. So coming to the second question, we will have to find out the total elongation of the bolts at the maximum load if the length between their heads is 50 meters. So here we will have to find out the total elongation of the bolts at the maximum load. So maximum load is nothing but due to the maximum load, the bolts are subjected to maximum stress. But here the working stress for the bolts is given by 10 kilonewton per meter square, and the maximum elongation possible, that is the total elongation possible, is equal to sigma L by E, where sigma by E is the maximum strain and L is the length between their heads. So here sigma is 10 kilonewton per meter square, that is 10 into 10 cube, where L is the 50 meters by E is the 200 gigapascal, that is 200 into 10 power of 9 Newton per meter square. So which is equal to nearby 1 by 400 mm, and in the options the right option is C. C is the right answer. Of water of cross sectional area 0.002 meter square moving with a velocity of 40 meter per second, striking a curved fixed symmetrical plate at the center. The jet deflected through an angle of 120 degrees at the outlet of the curved plate. Here it is a common data question. It consists two questions. Here the first question is the force of the jet of water in the direction is. Here the options are 5020 Newton, 6010, 4800 Newton and 2010 Newton. Coming to the second question, when the curved symmetrical plates move with a velocity 20 meter per second, the force exerted by the jet on the plate in the horizontal direction is. So here we have to find out the horizontal force. Almost two questions are similar, and in the first question we will have to find out the force exerted by the jet when the plate is fixed. Here force exerted by the jet in the direction of jet when the plate is fixed is equal to rho a v into v minus v cos theta, which is equal to rho a v square into 1 plus cos theta, where theta is the angle of deflection, which is equal to 180 minus 120 and is equal to 60 degrees, where A is the area of cross section, that is given by 0.002 meter square, and rho is the density of water, that is 1000 kg per meter cube, and v is the velocity, that is 40 meter per second. So substitute all the values in the equation and we get a value of 4800 Newton for the first question. So here in the option, the correct option is C. C is the right answer for the first question. Coming to the second question, we'll have to find out the force exerted by the jet when the plate is moving with a velocity of 20 meter per second. When the plate is moving, the force exerted by the jet is given by rho a into v minus u whole square into 1 plus cos theta, which gives a value of, we have all the values. V is the velocity of the jet, u is the velocity of the plate, and rho is the density of water, and a is the cross sectional area of the jet, which gives a value of 1200 Newton. So in the option, the correct option is D. D is the right answer for the second question.